The electronic structure of the atom. The chemical properties of an element are determined by the number of protons in the nucleus, as well as the number of electrons that are orbiting that nucleus. The electrons are responsible for bond formation, and as a result, they determine the structure of molecules that are formed. Electrons bound to a nucleus can be found in orbitals. We can never determine exactly where this electron is. However, we can determine the electron density. And this tells us the probability of finding the electron in a particular part of an orbital. An orbital, then, is described as an allowed energy state for an electron, and it is associated with the probability function that defines the distribution of electron density in space. Atomic orbitals are grouped into different shells, which are at different distances from the nucleus. Each cell is identified by a principal quantum number called n. When n equals 1, the lowest energy shell is closest to the nucleus. As n increases, the shells are farther from the nucleus and higher in energy, and hence can hold more electrons. Most of the common elements in organic compounds are found in the first two rows of the periodic table. This indicates that their electrons are found in the first two electron shell. The first electron shell, which is the n=1 shell, can hold 2 electrons. This first shell contains just the 1s orbital. The 1s orbital is spherical, and it is closest to the nucleus and lowest in energy. The second shell is the n=2 shell, and it can hold 8 electrons. 2 electrons in the 2s orbital, which is slightly higher in energy than a 1s orbital, as well as 3 p orbitals, each of which can hold 2 electrons. The p orbital consists of 2 lobes, and each of these orbitals are similar in energy. The only difference is how they are arranged in space. So one is on the x-axis, one is on the y-axis, and the other is on the z-axis. Each of these p orbitals will hold 2 electrons, and so the p orbital has 6. This gives the n=2 shell 8 electrons. Let's talk briefly about the electronic configuration of atoms. In order to discuss this topic, there are a few rules or principles that we need to discuss. The first rule is the Pauli exclusion principle. The Pauli exclusion principle states that each orbital can hold a maximum of 2 electrons, providing that their spins are paired. By pairing spins, what we mean is each arrow represents an electron, and they must be pointing in opposite directions. The off-ball principle describes how to build up the electronic configuration of atoms in the ground state. Basically, it says that we fill orbitals in order until we have the proper number of electrons, starting with the lowest energy level first. Here, we would first fill the 1s orbital. Once that orbital is filled, then we will move to the 2s orbitals. Once we have filled the 2s orbitals, then we move to the 2p orbitals. This is the off-ball principle. The third and final topic or rule is Hund's rule. And what Hund's rule states is that when there are two or more orbitals of the same energy level or of the same energy, electrons will go into different orbitals rather than pair up first. Here we have the 3p orbitals, which are of the same energy. Hund's rule says this will never happen. If we have 3 electrons, rather than pair up, what will happen is that each p orbital will fill with 1 electron before pairing begins. If we follow all 3 principles or rules, we are able to write the electronic configuration of the elements in the periodic table. Here we have elements from hydrogen to neon. Hydrogen has 1 electron. That electron is placed in the lowest energy level, the 1s energy level or 1s orbital. And so the electronic configuration for hydrogen is 1s, 1. Helium has 2 electrons. Both electrons are placed in the 1s orbital. And so helium has an electronic configuration of 1s2. When we get to lithium, which has 3 electrons, we place the first 2 electrons in the 1s orbital to get the 1s2 electronic configuration, and then the third electron is placed in the 2s orbital. The next element is beryllium, which has 4 electrons. Here we fill the 1s orbital with 2 electrons, and then we fill the 2s with 2 electrons. When we get to boron, we have filled both the 1s and the 2s orbitals. And so the 5th electron is placed in the p orbital. And here we continue following Hund's rule as well as the off-ball principle. We continue doing so until we have filled all orbitals with 2 electrons. So here, neon has an electronic configuration of 1s2, 2s2, 2p2, 2p actually 6 if you combine px, y, and z, which we often do.
Thank you for listening, and I will see you next time.